With the knowledge of association rules, it is possible to convert that a little bit into a classification algorithm. And that is what we want to discuss in this video, association classification. Association rules show strong associations between items that occurred frequently. The discovery of association rules is based on frequent item set mining, which has a set of precedents associated with another set of what we call a consequent. Now, the general idea of association classification is that we can search for strong associations still from the precedent and class label, which the consequent, instead of a set of items, we change that to simple class labels. And use the simplest example is that if we are doing a by class classification, then we can have a set of items as the precedent associate with a label of yes or a label with no. In the examples that we are about to see is that based on a set of informations, we can predict a person is going to buy a computer or not. And therefore, the set of conditions is going to be the precedent, and the condition of buying a computer or not, which is only about one item, as the consequent is going to be our class labels. Association rules can have many number of items in the rule precedent and any number of the consequent. As I mentioned, if we change that into association classification, now it is in the form of mathematical equation. You will be able to see that you can have a set of precedents of items of the conditions, and then the consequent is going to be only one class label that we want to make the predictions. So all association rules must satisfy the certain criteria regarding to, not surprisingly, their support and their confidence. The support is the proportion of the data set that they actually represent. So in this case, we are still using the same formula of the support based on how many item conditions that you have associated with the class label, and then we need to see how many of them occurs all together based on the total number of transactions. They need to meet the minimum support, indicating that they have enough occurrences that are significant enough for us to consider that as a rule to make our prediction. Once the rules satisfy the support, we still need to deal with the confidence. So now let's see what is the confidence looks like. Surprisingly, it's almost the same. Why is that? Because now you have a set of precedents. We need to see how many times they occur, and based on that, we can also understand this equation, indicating that based on that situation is occur, how many of the times that your class label or your consequent occurs on that particular situation. For example, if you are a student as the condition of X, all students has a computer. So you can see that when student associated with buying a computer is going to be the same amount of the number of students, then your confidence is 100%. On the other side, for the student who does not have a computer, which is going to be a consequence of not buying a computer, then you understand this confidence is going to be a 0% confidence, which is their accuracy. So the confidence and accuracy are the same thing when we are discussing about the association classification. So the equations for the support and confidence basically does not change at all. It's just like how you think about those items is going to be a different story and a different application. So if we look into an example, and that can help you understand even better, is that if this is some rules we have seen before, age equals to young and credit equals to okay, then that person is going to buy a computer. So saying that the support is 20%, confidence is 93% based on the situations that we have seen, and therefore the percentage of the tuples in D satisfy the rule antecedent, and then having the class label C is called a support of the R. So you can see that in this case, a support of 20% for the rules that we have seen, indicating that 20% of the customer in D in the database are the following situations. They are young and they have okay standing for the credit and belonging to the class of buying the computer equals to yes. So among all the transactions, 20% of those item sets satisfy the condition that we see over here. And now the confidence is the accuracy, which means the tests among all transactions of age equal to young, credit equal to okay, 93% of them buying the computers. On the other side, 7%, only 7% of them are not buying the computer. So saying that we have our minimum support and we have our minimum confidence set up to 20% and 80%, then this is going to be a rule that will pass the minimum support and minimum confidence, and we are able to use this as association classification rules. So saying that we want to do similar things on the data set that we have seen earlier in, I believe it's like decision tree examples, saying that these are the data sets that we have. At this time, it does not look very similar to our association rules example. So we need to make a slight modification over here. Take a look of the age. There are 3 different types of the ages, and therefore we can use some symbols, or we can use some code to represent that. So saying that A1 is indicating age less or equal to 30, A2 is age between 31 to 40, A3 is age greater than 40. So you can see that the first column has been modified into the A1 and A2, A3 representations now. Think about this. These items, if we look into one row, that can be considered as like one transaction. Inside of this transaction, a customer purchased or a customer satisfied A1, B1, C1, and D1 condition here. And that is something we are able to map the concepts of the data set that we have into our association rules example. So we basically has a mapping designed over here. Each column is going to be separated by different notations of A1 to A3 for the first column, B1 to B3 for the second column, C1 and C2 for the third column, D1 and D2 for the fourth column. And simply because third column and fourth column, they only have like 2 different values or the labels that we are able to see. And of course, buying a computer can be simply using yes or no to represent the class label column. So once we know this, we are able to apply our association concepts. So this support minimum, the support equals to 20%, since that we have quite a few items over here, 14 items over here. So if we need to satisfy 20%, that means it's equal to 2.8 times. That means it need to occur at least more than 3 times so that you can satisfy the minimum support of 20%. And that's why basically our minimum support count equal to 3. So if we do that, using that concepts, we now can do our association rule things. Think about this. Now, in all the grocery store examples that we have, how many items that we have? We have A have 3 items, B has another 3 items, 2 items, another 2 items over here. So in total, we have 10 items on the labels, on the attributes that we need to deal with. And therefore, if we list out all of them and then we try to count how many times they occurs, we are able to use the minimum support concept to find the items that we are interested in. And therefore, this is exactly the a priori concepts. Since all of them satisfy the minimum support count, we now need to combine them into 2 item sets. So of course, there's a lot of combinations over there. Think about it. So we have 10 items, so we need to, initially, since they all pass minimum support, we do need to make a lot of combinations. So from the first item combined with the second item, first item combined with the third item, first item combined with the fourth item, etc. However, there is one interesting observation can be made over here. That is indicating that A1 and A2 is not going to occur together. Why is that? Because A1, A2, A3 are coming from the same column. In this case, if their age is going to fit into one category only, it cannot fit into two categories. And therefore, based on the examples that we have, we are able, using the a priori plus some observations that we can make over here, to combine our two item sets. And therefore, by using that concepts, we can combine A1 with B1, A1 with B2, A1 with B3, and then A1 with C1, C2, D1, D2. So you can see that we use A1 to combine with all other possibilities over there. And the A2 is going to be the same thing. And then when we move into A3, we make all the combinations. Then we move into B1, B2 combined with all other choices, and B3, and then we can have C1 and C2 to make all combinations over there. Once we have done that, we can of course go into the database and then try to see how many times that we have counted for each two item set over here. So you can see that we are preparing for our precedents in our association rules. And therefore, saying that we have done all of those things, and I have a more complete example to be shown in the following slides. But before we go into that, make sure we understand the whole process. So saying that once we have done all the one item set, two item sets, three item sets, even four item sets, etc., we then need to calculate their confidence, which means that we want to use the items that we found, they pass the minimum support, attached to the class label. And then see, once we have made that, are they still satisfying the support? If they do, how's their accuracy? How's their confidence? So using our example of A2, we all know that A2 has passed the minimum support. The next thing is that we want to attach A2 with class label of Y, and then A2 with class label of N, to see which one has passed, if any one of them are passing. So once we go in there, we can see A2 and Y has occurs once, A2 and Y occurs another times, A2, A2 and Y occurs another 2 times. And therefore, the support is 4 out of 14. Congratulations, it has passed the minimum support. Then the confidence indicating that when A2 occurs, so A2 occurs 4 times over here, all of them occurs A2 and Y comes together. So 4 out of 4 times indicating Y. This rule has 100% accuracy, and that's something that we want to include in our association classification rules. Similar things, A1 and C1, since we know A1 and C1 did pass the minimum support, because we can see A1, C1 here, A1, C1 here, and then we have another A1, C1 over here. Therefore, it occurs 3 times, 3 out of 14 times past the minimum support. Now we want to attach that A1, C1, Y, A1, C1, N. So same thing, if we do A1, C1, and Y, we will realize there is no occurrence over here. A1, C1, Y is not occurring here either. A1, C1, Y, that none of them occurs. So obviously, A1, C1, Y is not going to pass the minimum support, so we are not even going to calculate their confidence. While we're calculating A1, C1, and N, we will realize 3 out of 3 times that they all occurs in this situation. So saying that if your data is A1 and your data is C1, then you are not going to buy a computer. Similar things over here, A1, C2, Y. Since A1 and C2 and Y, they did not pass the minimum support. Obviously, A1, and then when we goes to C2, Y, it occurs only once. A1, C2, Y occurs another time. However, our minimum support is 3 times, and therefore we are not going to calculate their confidence because that's some rules we are not going to consider since it did not pass the minimum support. So here's the whole process of finding association rules that passes the minimum support of the 20% and then saying that our minimum confidence or the accuracy is set to 80%. Therefore, starting with the same process, finding out all 10 item sets occurrences, all of them pass the minimum support. And now we need to generate the 2 item set combination using the a priori concept plus the observation of A items will never occur together or the B items will never occur together. And therefore, we would be able to generate the 2 item set, all possible 2 item sets as we see earlier. At this time, we also calculate their occurrences for the combination of the 2 items. And therefore, you can see that in this page, we have A1 with C1, A1 with C2, A1 with D1 that passes the minimum support. In this page, all the red rules indicating that pass the minimum supports in our examples over here. And then finally, we can see our B3, C2 passes, C1, D1, C1, D2, C2, D1, C2, and D2. One thing you can understand here is that since the column C and column D has only 2 categories, it is relatively more easier to pass the minimum support since we set the minimum support as a fixed value over here. Therefore, once we have done that, we can collect all of the 2 item sets and then prepare those for 3 item set generation. Once we have done that, you will need to combine different 2 item set rules and then generate a possible 3 item set rule. While we are trying to do that, take a look at this. If we use the first 2 rules, we may have generating A1, C1, and C2. At that time, you would understand again, C1 and C2 will never occur in the same transaction, and therefore you don't need to do that 3 item set calculation. So that's still the same observations that we were using. Once we've done that, you can see that when we combine A1, C1 with A1 and D1, we generate a possible 3 item set A1, C1, and D1. However, we still need to make sure that we do have a C1 and D1 rules that passes the minimum support so that has a possibility for A1, C1, D1 to be a 3 item set. So that is again the a priori concepts that the subset of the current set, all of the subsets of the current set need to satisfy the minimum support condition. So that we use these 3 rules to generate the first 3 item set. We then use these 3 rules to generate our second 3 item set. So if we do that repeatedly, scan through all the process, we will be able to generate totally 5 3 item sets. However, none of them actually passes our minimum support count. Under the condition, we set minimum support equal to 20%. Of course, if we lower that, these will pass, and then we can possibly look into the 4 item sets in this whole scenario. So once we do know these things, we can now prepare ourselves for the next stage, is that we use all of the items that pass the minimum support, attach that with the class label, and then calculate their support and confidence. So you know that we're starting from A1, A2, A3, B1, B2, B3. So all 10 item sets, we attach that with the class labels, and then we can start calculating their support. You can see that the A2, N has 0 occurrences, so that we can take a look of A2 and Y that occurs 4 times, and all of them are having the same scenario. So A2 do attached with Y. As long as you are A2, you are going to buy a computer. Same situation for C2 and Y. And here gives the examples of our support and confidence. So this is like one item set then attached with the class label, kind of calculating the confidence concept. So the confidence, to calculate the confidence in association classification is going to go through this method. For the two item sets, we need to do the same thing, attach the two item set with the class labels, calculate the support, calculate the confidence, and these are the rules, the two rules that we were found satisfying the conditions. On this page, none of them actually are passing the minimum support, so that we don't need to worry about any of these. So that when we comes to these slides, you see that there's only one rule that's passing the minimum support and minimum confidence that we have set up. And therefore, we would be able to have all of these 5 rules that pass the minimum support and confidence as the strong association rules. One thing you can understand by looking into these 5 rules, there's only 5 rules. And that is going to be a very big different story with the classification algorithms. Because when we have a classification algorithms, once we train a training data set, we basically use that model to predict all testing data set. That's what we have seen. And that's something you guys have done in the projects. However, when it comes to association classification, you will understand that the rules are set over here. There are some situations you will probably not able to make predictions. So saying that if the first attribute is A2, then we can make the prediction. If the third attribute, C2, is the situation, we can make the prediction. However, if that comes to like A1, it has to be A1, C1 so that you can make the prediction. If that's A1 and C2, or A1 and C3, something like that, there's a possibility that you are not able to make the predictions. For example, A3 and C1. So A3 and C1 is not included in any of the rules over here. In this case, we are not able to make the predictions because we don't have the rules that can cover that. So the coverage, that's another important perspective in association classification, is that the rules you generated may not be able to cover all the testing data sets. So saying that there's only 6 out of 10 data that you are able to predict, then your coverage is 60%. That is totally associated with your minimum support and minimum confidence, because if you lower your minimum support and confidence, you may be able to generate much more rules. However, there's a possibility that your prediction accuracy will go down. So there's a big trade-off between association classifications over here. One advantage of association classification is that these rules are super useful. They can be translated easily into human language, so that we maybe generate knowledge out of it. So there's some advantages and some disadvantages in the association classification here. And of course, if we use these knowledges, we can make the rules very, very close to English, human languages. So for example, A3D1, A3 indicating if your age is greater than 40, you have fair credits, then you are going to buy a computer. That's the rules has been presented over here with a very, what we call a readability perspective in the classification algorithms. So that basically gives you a summary or a flavor of what is association classification. Also shows you the whole process of how we are able to generate that. And therefore, The last slide over here is a class assignments. I want you guys to work on it. In this case, you have a much smaller data sets now, so it should be relatively easier to generate the rules that are satisfying the conditions that we set over here. Minimum support equal to 30%, minimum confidence equal to 60%. However, you need to understand, I also make some modifications. So if you pay attention to the assignment, we want to find the rules to predict if a customer is a student. In other words, now we are going to use the third column as the class label, using this as attribute, A as attribute, B as attribute, D as attribute. Buying computer or not is another attribute to predict a student is if the customer is a student or not. So now C1, C2 becomes the label. That means that you need to use this for A, B, D, yes or no, to generate the precedent of the association classification rules to make the prediction, which means the consequence is going to be C1 or C2.